Yeah, thank you. So I welcome Dr. Austin Okoli.
Yeah, thanks. So I would
okay, why PPS?
Yeah, please just.
I will also post the Menti form if you're still interested in applying. Please, you won't hear for us because we have to go through. If you have applied already, please give us few time to go through it. We will definitely write to you once we have a mentor to be assigned to you. And also this class will also be recorded too. So, and once by either by the end of today or by tomorrow, it will also be on YouTube too. So please, you have access to it to listen to it again. So I will also share the WhatsApp group link. Somebody is asking for it. I will also share the Menti form and the YouTube. I think the YouTube was already shared before, which I will share them again. Thank you very much. Over to you, Austin.
Yeah, thanks. So I'll share my screen. Okay, then I can zoom. Can you see my screen?
Yes, I see your screen.
Okay, thanks. So yesterday we started data types, and we also talked about some basic things like, you know, as we did yesterday. So today we would be diving deeper into, you know, some of the functionalities of simple Python programs. Then yeah, I might go faster today, but yeah, just follow. Yeah, so today we'll be starting with the control structures. So they are just simply flowchart methods that, you know, represent execution. I mean, that represent executing flow of, you know, programming languages. And so there are three types, which we have the sequential, then we have also the selection for decision making, then we have repetition, that is loops. But first, let's start from, I mean, some of the common control structures we have is, you know, the if-else statement. This is based on, you know, for, for decision, something like that. So just as the statement implies, so when you make a statement, you have to condition on that statement. And so when that is, something would happen if the condition is satisfied. Otherwise, it doesn't happen. For example, so what do I mean by, you know, this kind of conditional statements? So here is a statement. We are just, you know, so we are asking 5 greater than 3. So in Python, usually when you use this kind of conditional statement, it returns a Boolean, you know, expression. So I would just go up and type this. Then, you know, it's okay. It's going to return false. Yeah, true. Yeah, because 5 is greater than 3. Yes. Okay, it's still running. Yeah, so we would get 5 is greater than, we'll get true. And the reason why we are seeing a true there is because this condition is satisfied that 5 is greater than 3. But let's try to reverse the statement. It's going to say false, and because, you know, 3 is 3 is not greater than 5. So logically, it's going to return a false. That is not true. Now, how do we use it, to condition on, on further action, something like that. So now we have said, okay, 5 greater than 3, true. But, it doesn't do anything because we are not, conditioning on what to do if, the statement is true. And that is where if statement comes in. So if you put an if in front of this statement, what it means is that if this statement is true, then something would happen. So for example, let's print just as we did yesterday, hello world. So now we are telling Python that already that this statement would return true already. The statement that is been highlighted. And now what you are saying is if true. So indirectly, the 5 greater than 3 you are seeing, in the real sense, it's returning, a Boolean response. So true. Okay, someone said I should share the link to the okay, please just give me a moment. Because I did yesterday, but I will do now again to share. Yeah, just give me a few minutes. Yeah, so I shared the link now on the link on the chat. So now what we are saying is if true, and when something is true, it means just go ahead to whatever. So when Python recognizes that this statement is true, it's going to move to the next line. So it's just like a sequential thing. It's one step at a time. So this is more or less step 1. Then if this is true, it jumps to, step 2. That's just it. And when we print this, you see hello world. And the reason why this is, the reason why this is printing out hello world is nothing, just because the first line is, the condition is satisfied. Now let's reverse the statement 5. Already, that 3 greater than 5 would return false. And when something is false, nothing would happen. Because the if statement only executes if it's a true state. If it returns true. And so what you're saying is if true, do this, which makes sense because it's true. But because now this gives us a false. If false, it's not going to do anything because Python doesn't execute something. In this particular statement, the if statement only act as, the first consequence of this logical expression, which is true. And if it's not true, nothing would happen. And if we run it, or you can also run it, you see nothing displays. This is because this statement is false. However, we can continue to, condition, because sometimes the if statement must not necessarily be true always, or we are just, trying to do something based on, certain conditions. Okay, for example, now we said if 3 greater than 5, it's false. But I can decide to say else. So the else means, okay, if nothing happens, just, move to the next line. And we can just say, yeah, else, print, yeah, print else. So, so what you see now is that because the first statement doesn't, nothing happens for this, for the first, block of this expression, then it jumps to the next statement. And this statement means otherwise, that is any other thing except from this first block. But let's be more, let's go into something that, we can, that makes more sense. So just, let's move to the next line. So think about, you have 3 variables, 5, 4, and let's say 2. And now you want to check between these numbers, which is greater than which. We just want to do a combination of these 3 statements. And you can say if 3, because I've been using greater than or less than, so you have to know there are some logical syntax. And we have the less than, which is what we have done. We have the greater than. We have the equal to, so that is, this means if it's just exactly equal to. Then we have not equal to, that is the exclamation, and this is not equal to, not equal. And we also have, less than or equal to, less or equal to. Then we also have greater than or equal to, greater or equals. This is less already. I think this is this is something that we know already from our basic maths. Okay, I wrote popular, greater than, greater, and this is equals. So I can move it to this line so you can see this is greater. Yeah, if you have any questions, just drop it on the chat. So we can use the multi block comment. So now this is less, greater, equals, not equals. And what this not equals means, whether it is greater or less, but as long as it's not equal, then less or equal to, that is, it must not be, it must not be greater. Any other condition would be satisfied. And this, it only means that it's either it is greater or equal. So let's play around with these 3, something. And okay, so let's start from, let's check is if A equals B, so of course, what do we expect? Sorry, A is equal, sorry, A is equal to B. So what this means is we are making a statement because, we just want to play around with multiple statements. And, let's start with equal to. Already we know A is 5 and we know B is 4. Obviously A is not equal to B. So you already know that this highlighted statement would throw a false because that condition is not true. And what do you think would happen? It's not going to print out anything, we know. So let's go ahead to say else. So there is, in Python, we have, the else if statement. So we use the else if statement if, we want to continue, we want to continue the condition. So be very careful. The difference between else if and else, I'm going to explain. So now let's go ahead. Let's continue checking, between A and B. So else, if A is less than B, print A is less than B. So already we know A is 5 and B is 4. So if you say A is less than B, what do you expect? We know it's a false statement. So it's not going to print anything. And why we are not seeing anything is because Python checks the first block, nothing happens. It jumps to the next if statement, nothing happens. Then it continues to search. So let's try the last one. So I think this is so when do we use else and else if, and else if, so which is elif in Python. So you have to understand that the only condition to use else is if you have tested all combinations of conditions. That is, every condition has been tested. And then you say, otherwise, any other thing else apart from these conditions, then just do this. However, I don't think we are done because, you know, if you want to really compare two numbers, there are three possibilities but there are three there are so many possibilities because already we started with equal to, you know, less, strictly less than, and this is strictly less than. But I mean, for just to explain, I would be doing it one step at a time. Why I don't want to use less or equal to years, because at the end of the day, you can also, these two statements can just, you know, you can use to represent these two blocks. And why is it so? Because if you say less or equal to, what it means is you are just running less, that is this, and you're also doing this. And this is because the first less here is this, and the second, which is the equal to, is this. Exactly. So to save yourself writing too many lines, you can just use, you can erase this, put if, and just put less or equal to. And you see, it's not still going to print anything. And this is because Python checks, is A less than B? No. It jumps to the second one. Is A equal to B? No, so it doesn't do anything. So let's continue with, is A greater than or equal to B? And here I'm not going to say A is less than B because we are testing two conditions, less or equal to. So we say A is less or equal, A is less than or equal to B. And of course, you know why I'm now using less than or equal to, because the condition here is now, you know, it serves as for both, you know, less or equal to. And for the second statement, we have print A is greater than or equal to B or equal to B. So what do you think would happen now? So for the second statement, we are asking, is A greater than or equal to? So what Python does is it checks, you know, each of these, conditions one at a time. So it starts from greater than, it checks, is A greater than B? Of course, it's true. It checks again, is A, I mean, Python just needs one statement to be true for you to, you know, to proceed. So indirectly, once it checks this and this is true, it doesn't even, it's not going to, you know, continue with the equal to statement. And simply because we have already in the first line of code, we have included the equal to, we can just neglect it because we are just, that would be a repetition, you understand? So we can just, we can remove that equal to part because we already tested it here, okay? And if this were to be true, then we know that, you know, it's equal to. Otherwise, it's either it is strictly greater than or less or equal to. And once we print this, okay, it says a syntax error. Okay, so yeah. So when you use else, you don't need any condition, right? And so the reason why this is throwing syntax error is because the else statement doesn't need any condition. It doesn't need any condition. So this would only work if you put, you know, if, that is, you are still checking. So once there is if in front of the else, you still have to put the condition, right? And we say A is greater than B. But when do we use else? Like I said, if you have tested all possible conditions, for example, in our case, we have checked if A is less than B, 1. We have also checked if A is equal to B, 2. That means any other condition has to be greater than, because it makes sense. If you are comparing two numbers, it's either one is less or equal or greater. It cannot, you know, it can't go more than these three conditions. So there you can use else. And once you use else, you have to erase this, you have to erase that, you have to erase this guy here, so it's still going to run because Python already recognizes that, or more or less, you already know that any other else statement has to be greater than. So it's just something quite logic. So for example, if you look at this line now, there we have age equal to 18. Let's say this is the age of someone, and you want to check if the age is greater than equal to 18, print you are an adult. And already we know that our age is 18. So the age is a variable that stores this information 18. So we want to check if that age is greater than equal to 18, then we can say you are an adult. Else, and this is the reason why you use else, just like I've described. Already we have checked if the age is greater, if the age is less. Aside these two conditions, the next one has to be not an adult, which is minor. If you say else if age is less than 18, well, of course, the code would run, right? But it doesn't make sense because already you know that these two conditions, after these two conditions, the next one has to be this. So you can just ignore this and just use else. So always be very careful when to use else if or else. And you have to understand that this block stops immediately after an else statement. I mean, that's just it. It stops after an else statement. So that is, it's not going to go further to check if there are, other conditions. Yeah, so we can, if you modify the age, like 20, no, I don't want to use this. Is not mature. I think this should be the reverse. Sorry. Less than and else. Yes. So in this case, we are saying if this person is less than or equal to 18, we can say it's not mature because here it's not an adult or it's a minor. So the way you set your condition, it's left to you. So whichever way works for you, you can set it from the reverse. You can set it from anyhow. If you are saying age is, if you are checking if the age is less or equal to 18, then you know that your the consequence of that condition has to be that is not mature. Otherwise, is getting mature, something like that, or is mature. Let's just put is mature. However, I can decide to say if age is greater than or equal to 18, I'm just going to flip the the condition, like the consequence of the statement. And this is because you want to ensure that age has to be greater than 18 for this condition to be true. I mean, for this person to be mature. The other time we use less than, and that is because when the person's age is less than 18, we assume that the person is not mature. So you flip the statement, and you see this will print is mature. But if you print 15, and if you say, if you run this code, Python checks is age greater than or equal to 18, obviously this statement will be false because 15 is neither greater nor equal to 18. So when this block doesn't execute false, it comes to the next else and says, okay, it's not mature. Now that's for if statement, very straightforward. Now for loops, just like the word implies, loop. So when we loop, we more or less like, we are counting. It's like, a counter, and you really have to understand, certain things when it comes to for loops. So for loops can be tricky, but of course, if you are so used to it, then you would know. Yesterday we talked about range, and we explained range. We know what range is. When you print range, when we check the documentation, we found out that range takes in one or multiple argument. So when we say 5, what you're indirectly saying is, give me number from Python. Like I said, Python starts its indexing from 0. So Python is going to return 1, 2, 3, 4. And you remember I said Python doesn't get to the last number. So in this point, 5 means stop. 0 is start. So when you put just one number, Python would assume that you are starting from 0. So you're saying 0 to 5. But when you come here and you say 2 to 5, you're telling Python, okay, give me, I'm going to print both statements, and you would see why, what I mean. So you have to specify the range. If you are not starting from 0, especially if you want to index, then please be sure to specify, your start and your stop. So in this case, it means that our start is 2, our stop is 5. If you only put one number in the range function, it's going to, by default, start from 0. And you see the difference. The difference here is that for the first line, it's starting from 0. But the second one is starting from 2 because you specify the start. And I didn't talk about this yesterday because of this for loop, and I think this is the best time to talk about it. Now, apart from even specifying the first and the stop, there is one more, condition. And if you look at my screen here, it just pops it. And we have the start, we have the stop, then we have one more called step. And this step is what Python will use to partition the start and the stop. So if you want to tell Python, okay, from 2 to 5, maybe give me a step of 1. Of course, it's still going to be the same because by default, it is 1, right? But if you say 2, what do you think would happen? So Python is going to print out 2. Python is going to, Python will discretize, the numbers by, by 2. By a factor, not a factor, but an addition of 2. So what it means is it starts from 2. The next one is not going to be 3. The next one has to be 4 because it's going to add 2. So it's like the step we are defining here is what Python should add to the counter. And now we are going to come here and we would print it so that you would see what this actually does. So for the first statement, that is this is straightforward. If we print it, it's going to print 0, 1, 2, 3, 4. And you know why? Because we didn't specify the start. Python starts with 0 by default. And you know already that Python doesn't get to the last number. It stops because Python index starts from 0. So this, Python automatically assumes that, okay, this deficit, has to be a number before because it starts from 0. It doesn't start from 1. Instead of getting 1, 2, 3, 4, 5, you are going to get 0, 1, 2, 3, 4. This is because we still have 5 numbers, but you are starting from 0 because Python indexing starts from 0, not 1. And let's try the second one. Let us change now 2, 5. And what do you see? Python starts from 2. It doesn't start from 0. And what if we specify one more condition, which is the step, that is the counter? Python will just print 2, 4. Yes, Python will print 2, 4 because you already know that by default, it would never get to 5. Even if we put 6 here, you should know that Python would never get to 6. So Python will still print 2, 4. But if you put 7, because the number Python gets to is a number before the stop, which is 6, then we are going to get a 6. And you have to be careful how sometimes you have to check what this range you are defining, what it prints. And because we have specified a counter loop of 2, that is why Python is adding 2. But if we remove this starting point, let's say 0, and in Python, if you do this, nothing would happen because it assumes that you are starting from 7 and you are stopping in 2, which is not possible, except you use the the inverse range. So so something like this would still work, as we can see. So it's going to print 0, 2, 4, 6. You understand? This is because we we didn't specify we specify a starting point of 0. Okay, so the next one has to be yes. So before I talk about okay, I might talk about that later. So now let's talk about while loop, or rather we can just, I think if we can reverse this. So yeah, so now so I think it's nice I talk about the reverse. So if you want to loop from the reverse, you have to use this reverse. That is, Python already, we know the start point is 0, the end point is 7. And when we use the reverse function, just wrap the range inside the reverse, it's going to flip. It's going to print in the reverse. So if you remove the reverse, we know that we are going to get 0 to 6. But if you include the reverse, you get 6 to 0. And this is very useful. The reverse is very helpful when we are trying to probably want to loop through, in the reverse, probably want to access item from this from the end to the beginning. And this makes sense. But if you are going from the beginning to the end, then you can use your range and you can specify your start. But by default, it's 1. So if you don't specify anything, it's still 1. Now, the while loop is just more or less as for loop, but while loop expects a condition to be satisfied before it stops. For example, for for loops, it doesn't care. If you say print from 1 to 1000, it's going to just continue printing. But the while loop, just as the statement implies, while. So while something is happening, just continue doing this, otherwise stop. So for while, it's always the case that we set a counter. It keeps track of the condition. And we are saying, because now we set the counter to 0, and we are saying while counter is greater than or equal to 5, okay, we can put max. So let's define the max. So let's assume that we want to set the maximum to be 5. That is, I want something to be happening while this counter is less than this max. Once the counter is no longer less, and strictly less in this case, because we are not using less or equal to, we are using less. Once you are using less, it is strictly less. That is, even though they are equal, it would fail. The condition would not be satisfied. So what it means is that while counter is less than max, continue printing the counter. But you have to increase that counter, otherwise this loop will run forever. If I delete this and I run this code, it's going to run forever because nothing is happening. You are not increasing this counter. So what it will just continue to, what you're just going to see on your screen is it just keeps, printing 0, 0, 0, 0, 0, 0, 0, because nothing is happening. But if we increase the counter by 1, and this plus or equal to here, what it means is we are adding 1 to the existing value. So it's always, so for example, if you have a equals 4, and you want to add, let's say, you want to add, let's come here. So first I define a to be 4, I print a, and then I want to add 2 to a. So you can just easily, overwrite this a, and you are going to see 4, 6, because the first one is just the a we initialize as 4, but the second a is because we have added 2 to that a, so it's going to overwrite it, okay? But we can also compress the statement as, instead of just repeating a, we can just, delete this. Let's just, so it's still going to do the same thing. So, and that is what you're seeing here. What you're seeing here is you're just adding 1 to this counter, and it's overwriting the, the previous counter. So, and that is why this counter would be increasing. So when it prints out the first one, which is 0, it's going to add 1 to the 0. We get 1. It goes back to this condition. Check, is 1 less than 5? No. it will print 2. It adds, it will print 1. It adds 1 to that 1. We get 2. It checks, is 2, less than, 2 is less than 5. It's still true. It continues, it prints 2. Adds 1 to the 2, 3. And once it gets to 5, it's now going to say, is 5 less than 5? Because 5 is not strictly less than 5. The loop would stop. And that is why you see that the loop stops at 4. Why it stops at 4 is because the counter 5 is not less than 5. 5 is not less than 5. You can try to check it out. 5 is not less than 5. So when you say something is less than something, it has to be strictly less than. But if you say 5 less or equal to, even though this fails, of course, the equal to still works, so it's going to print true. And so you have to be sure when to use strictly less or equal to. If the condition is such that you want to get to the last point, for example, if I want to get to this max, I want to assume that, okay, the counter can get to 5. Anything above the max would not work. Then this would print 0, 1, 2, 3, 4, 5. Yeah, this is because the last condition, is satisfied. 5 is less or equal to 5, as you can see here. And that is why this is able to print out it's able to print the last 5. And when it adds a 1 to the 5, that is 6. 6 is not less or equal to, so it's going to stop. And so that's just the reason. So while would run until a certain condition is satisfied, then it stops automatically when that condition fails. For for loop, you just want to loop through. It doesn't check for any condition. So while loop is very useful when you are checking the condition. So you want to actually check if something is actually true while something is happening. Otherwise, just stick with for loop. Now there's a list comprehension. We have talked about list at the last time, and list comprehension is just a way to define for loops. Something like it gives us this, instead of trying to do some appends, so I'm going to explain. So of course, you already know from yesterday's class that the square bracket is for the list, right? And when you do this kind of thing, then you are initializing, a list, right? And so what it's doing now is that it's going to check. It's going to first, okay, we know this range. We know what this would do already. Range 1 to 6. That is, we're expecting a number 1 to 6. And for X in this, you know that it just, we can just try it one step at a time. We have already talked about for loop, but already you know what this would print out, right? So this would print 1 to 5. And what this already would spit this result. So what is this? Now, what you are doing here is you are saying, okay, for X in range 1 to 6, I need X times X. Already, you know that X takes on values between 1 and 5, which are these numbers that I can have printed here. So what it's going to do is it's going to say 1 times 1. We are just multiplying it with itself, just like square, right? And when you do list comprehension like this, the result will just be stored in that list. And for the for loops, it will just be automatically, appending, the next results in the loop. And what this is simply doing is it's going to already, that X takes on values between 1 and 5, strictly 5, including 5. And this X times X means, okay, the first one is 1. 1 times 1 is 1. That is what you see in the result there. The next X is 2. It's going to 2 times 2, 4. The next X is 3. 3 times 3, 9. The next X is 4. 4 times 4, 16. The next one is 5. 5 times 5, 16. And that is why you see that, but we can also print, we can also, get a list of squares of numbers in a list in this range. But sometimes it's always a good practice to, write clean codes, especially, just ensure that instead of writing codes in 3-4 lines, why not just do it in 1 line? It makes more sense. For example, if you want to do it in a way that, okay, maybe you are practicing, you want to really understand how it works. What you're going to do is this list you would initiate somehow, let's name it square. We initiate the list. We instantiate the list. That is, it's an empty list. You can see, we can even print it out to see. Print, let me use squares here because it's still the same thing. So let us print the squares. It's an empty, oh, okay, sorry. So it's an empty list. And now we want to fill, I want to fill this list with the square of numbers within this range. So let's just do it.
Hello, sorry, there's a question.
Okay, thank you.
Somebody asked that, how are you able to have numbering on each of your cells? So I just wanted to show it. I think it's on the side. If you go to settings, you can.
Okay, you mean your Colab is not giving you these numbers?
Numbering, yes.
Okay.
I think the reason is because if you go to, you see the cursors on that your cell on the left, on the right hand side at the top of your cell. Yes, you go to the third one, the next one, the one that has setting on it, the one that has this star. Yes, click on it. Then yes, you can go to the bottom. You see show line number.
Thank you. Yeah, you have to set your line numbers. Yeah, thanks, Tayo. Yeah. So you have to set it. If I off it now, I think the numbers. I think when I load it, also it's going to.
When you load it, yeah.
Yeah. So yeah, you can always the lines are just again. Okay, I didn't save it, so I think when I save it now.
No, it's just yeah, exactly.
Yeah. Okay. So okay, thanks. So just set the number, show line numbers. It's always good to use the line numbers. I like it because if you have an error, it can easily point out where the error is coming from. Okay, now let's continue with, let's try to fill this list as we have defined an empty list. Already we have our range from 1 to 6. So what do we want? Already we want the square, right? We want x times x, right? And let's just store the result in y, right? Then we can now, in Python, there's what we call append. So you can append, so what we are doing is, I can even just, I don't need to even write, I don't need to store it in a variable, so that I don't write multiple lines. So what we are doing here is we are taking this list. Okay, before I talk about that, let me play around with something. Let's create a list, 2, 3, 7. And I want to add, let's say, I want to add a number, let's say 10 to the list. Let me print the list before and after. So what you see is that, this list 237 is what you see here. And when you append this line of code here, we just append the 10 to this list, right? And it's just going to place it, after the last number. Well, you can also use the insert. For insert, you can strictly specify the position where you want your 10. This is also very useful probably when you are, you're appending your list and you're also trying to, specify, the particular position where you want this number to, for example, I can say, okay, insert. Now I want to insert 10. The first argument is the index. So let's say I want to put it in index 1. As you can see from this description here, the first argument is the index, and that's the difference between insert and append. Append, we just take the number to the last. It just places the number after the last item in the object, in the list. But for insert, you can specify. Now, let us insert this 10 in position 1. So what it will do is, you already know that the 2 is in position 0. Python will come here and insert that 10. right? So let's print and let's see what our result will be. So like I said, the insert would place the item in the position you have specified. Append would just take that item to the last. So that makes sense. So let's proceed. So what we are doing now is that already, you know, the X are these values, right? 1, 2, 3, 4, 5. And we want to append X times X, that is the square of each number, to this empty list we have, you know, initialized from start. Sorry, I can print my squares here. I can print my squares here. And you see that what you just get is exactly what we have here. But, you know, if you look at this, if you look at the two cells, yeah, this code was executed in 3 lines, but this was just executed in 1 line. So which do you think would, you know, would make more sense? And even for, you know, computation time, you know, this is even faster. The comprehension is faster than this, you know, append. I think this scales linearly or thereabout, but this, you know, is, it has a lower runtime, especially if the number is very large. So also it's a good practice, even though you are writing programs, always ensure that, okay, you write it clean, and for also computational time, it's faster. So for the basic arithmetic operations, so we have talked about list, we've talked about control structures, for loops, while loops. We have also talked about, you know, appending items to list, also to insert. Now, what are the basic operations? It's very straightforward. I won't spend much time here because we can just easily add 2 numbers. We want to add 5 to 3. You sum the result, you get 8. Very straightforward. For the subtraction, we can just use the subtraction key on our computer. Gets you this the difference. For multiplication, we use asterisk. It gives you the product of the 2 numbers, and the 2 numbers here is just 5 and 3, and you get 15. We can also, you know, we can divide and get the result, and we can also get the modulo. The modulus is just, you know, it gives us the remainder. So after we have done a particular division, what remains? You know that our A is 5, our B is 3. So when you say A, and the syntax for modulo is just this percentage. So what it does is it's going to check 5 divided by 3 is 1, remainder 2, and it's always going to print the remainder. This is also very helpful. Sometimes if maybe you are running a program and you want to print out statements when, you know, I mean, you don't want to do it for every for loops. Maybe you want to do it when this is this. I mean, we can even do an example. And I can just quickly use this for loops. Maybe this would make sense. So let's just try to play around with it when also it's very helpful. For example, I want to print a number from 1 to 100. I can just delete this. I don't even need this. I don't need this. Now, but you want to be printing X. Probably you don't want to be printing X all the time because it makes this, it's going to be very long, especially when it's really big, like 1,000, and you don't want to see, you know, 1, 2, 3, 4, 5, 6 up to 999. So what you can just say is if X is hash 100, so what does this mean? So like I said, already you know that this statement would print a remainder, right? Right? That's the remainder. So that's the, I mean, that's the whole idea of modulo. And what I'm saying is that, okay, even though I'm looping through 1 to 1,000, only print out X when I divide X with 100, the remainder is 0. And already you know that the only time X modulo 100 would be 0 would be X equals 0, X equals 100, X equals 200, X equals 300. I mean, perfect divisions of 100. And what you're just going to see is printing x equals 100, printing x equals 200, because we started from range 1, and that is why it skipped that 0 part. But if we include 0, of course, 0 modulo anything would always give you remainder 0, right? So if you're very familiar with simple, high school modulos, you would really understand. And, it's always very helpful. I mean, this is also one of the cool, you will be seeing this when we start doing projects. You want to print, the performance of your machine learning models at probably certain iterations, and this is very helpful. You just want to see, you just want to see what's going on at a certain point in time. And this is also very, very helpful. So let's proceed. And exponentiation is just raising to the power. Yeah, you can, this is just raised to the power of something. So when you raise a to b, that is 5 raised to power 3, it's just, multiplying 5 3 times, and it gives you 125. You can also use this. This also, I think, okay, that's in R. It doesn't work in Python. So yeah. A greater than a raised to power b is 125. Okay. Okay, and there is also a floor division. What this floor means is floor is going to it's going to floor the division. It's going to give you the lowest number that is less or equal to to the not the real part, to the integer part of the floating result. Something like, because already 5 divided by 3 would give you 1.66, just as we have done. 5 divided by 3, yeah, give you 1 point. And what it's going to do, it's going to return a number that is less or equal to, this part. And let me, to be very sure, just to give you a context, for 7 divided by 3, you see 2.333. When you do something like, when you floor it, when you add 2 double slash, it's going to just floor it. And that is what it does. So there is a difference between floor and ceil. You can also use ceil. Ceil would return the smallest integer that is greater than or equal to x. Yeah. So, and that is the difference. So imagine you have a result like this. Like I explained, floor, there's a math.floor function. It works also based on this this double division. Even though you might see that math.floor 3.7, you would expect that Python should approximate this result to the nearest whole number, which is 4. But you have to be careful when you are using these functions or something. So if you want a direct approximation to the nearest whole number, that is, once the decimal part is greater than 5, then we can always approximate. But if you use floor, floor would not mind, floor would not care. Even though this is 3.9, floor would still return a 3. And this is also very helpful when you want to do a perfect division. Maybe you want to avoid floating numbers, then you can use floor. But if you want a direct approximation, you have to use ceil. So you can see the difference. Ceil would just approximate this 3.7 to 4. And yeah, just like we also have here. Yes, so from the negative part, that's just the reverse. The smallest, then the largest. So as you can see here, it's not going to approximate it to -4. It's going to approximate it to -3 because -3 is greater than -4. So you can just look at the definition. Yeah, I defined it. It returns the largest integer less or equal to x. In other words, it runs down x to the nearest whole number. And the other one is the smallest integer greater than x. So now let's go to function. So what is a function? Function is just something that we use to to perform a particular, to perform a task. And it's always good to, to arrange our code, to kind of structure our codes in ways that, we have things that are doing things. And so you don't just write it, you don't just write too many lines of code. You can just write it in a clean way. Okay, this function would do this kind of thing. As you see in this place, this function is responsible for greeting, for greeting people. Let's say hello. So when we print this, so how do you define a function? We use the def. So it's I think it's the word called for definition or something. So we just define def. We define. So in Python, it comes with a def, def. The next thing has to be the name of the function. Here we want to give the name of the function that greets people hello. We want to name it greet. So this is the function, right? And you have to, when you are using things like, functions or, control structures, functions or anything, we have to use, these double dots just to, ensure that the program runs. So it moves to this, because, so this is a block of code. You have to understand it's a block. So when you're writing a block of code and you know that this block is just doing one thing, then you have to always use this, as, to ensure that it's a block. And the moment you remove, let's say, I run this kind of thing. So Python now sees this thing as not a block, just like 3 lines, 3 separate lines, this, and this. But because it's one function, so we have to, this is a block of code. And when you want to execute your function, you just have to call the name of your function. That's just it. You have to call the name of your function and with the bracket. And that's it. So what Python will just do is to print this hello. Now, let me erase this so that we can all see. So what I want to do now is, now if you look at this function, the function just prints hello. Nothing happens, and that's just it. Now, that is what I would have done in this second line, but I will still focus on just this line. So think about this function printing out not just hello, but prints out the name of someone, like, or whoever comes into a building and it says, okay, hello, John, or hello, just greets you by your name. And there is what we call parameters and arguments in Python. These arguments are the things that, the functions we take in, the function will take. So in this function, it doesn't take anything. And that is why if you focus on these parentheses, there is nothing inside. There is nothing inside. It's just empty. It's empty. And in this case, the function doesn't take any argument because we don't need anything. Just print hello and that's all. Just print hello and that's all. Now, what if I want to print the name of someone? I can say, okay, hello, Mark, right? It's going to print, right? But every time you call this function greet, it's always continue to print hello, Mark, hello, Mark. We don't want to print hello, Mark, because I'm not Mark. Not everyone is Mark. So you want the function to take some kind of, name of someone, and it would use that name to to print out the hello plus the name. Why don't we just add one more, one argument in the function that takes the name of someone? And instead of always printing Mark, we can just, always print out the name. Okay. And okay, let me don't use this F string, yeah. Let me just, yeah, we'll talk about that later. Yeah. Yes. So what did I do? I didn't do much. So this was empty before, and this was just hello. I mean, that was the first code we wrote. But now I don't want hello always. I want to print out hello plus my name, right? And let's say my name is Mark. But if someone else would come, that person is not Mark. And this function always print Mark, so it doesn't make sense. I don't want Mark always. I want to add an additional feature to the function that takes in an argument. And that argument is just the name of the person. And instead of just printing out Mark always, just print out the name of the person. And mind you, the way I put this comma after this string. So this comma means additional, we can add something else, which might be, a defined variable. And this name holds an information about the name of that person. And if we come here and run this code, it's going to print error. Because initially, the reason why this code would work is because there is no argument in this parenthesis. That is the argument of the function. It's just empty. It doesn't take in anything. It doesn't take anything. But now we have included an argument. So think about, so an argument is just something that you feed into something. It's just like a garbage in, garbage out thing, right? So if just like you're driving a car expects you to a car expects something from you. It could be maintenance, it could be fuel, water for the radiator, and anything you can name it. So this is just what a function looks like. In this case, this greet function needs a name. If you call me without that name, I'm going to throw an error. And the error you see here is greet missing one required positioner argument. Now, the word positioner is very important here because what it means is that there is an argument called name in the first position of this function greet that is missing. And if you don't supply me the name of that person, I won't work. So that means I have to supply the name. Let's say for me, I am Mark, and now it works. Now what it's going to do is when you call this function, and when you call the greet function, right, this Mark that you have fed into the greet argument will just automatically come here. It would replace, it's just like you are saying indirectly name equal to Mark. I mean, that is what it's just doing in the background. So we are just assigning, because this name is an argument, it's expecting something. So, and we have fed that, that argument with Mark. It just automatically inherit whatever you put in this bracket. And it's more or less, we are just defining the name of a person. And once it's defined already, then Python will just say, hello, name. And you know already the name is Mark here. And that is why you see it prints hello Mark. But I can decide to say, okay, I am John. It's going to print hello John. And this function makes sense now because it can greet someone by the person's name, by just feeding in the person's name. And what if I want something else? I don't want, just hello, whatever. I want hello John. Yeah, we could think about, let's say, so, okay, probably not a question. Let's just make it like a statement. Hello, John. I am, or you are, so years or something. So let's add more arguments to this function. So let's don't make it just hello, hello, like plus the person's name. So what we can do is probably we can we can just modify this function. Let's just use I am. Let's assume you are, making a statement of yourself. Okay, I am John. I am so years old. It makes more sense. So because I want us to, add more parameters, to this function. So I am John, and of course you can also use the plus. So in Python, when you add two strings, it just concatenates them. It just concatenates them. So if you say A, B, C plus D, E, F, so it's just going to concatenate. But if you leave a space here, it's just going to give us that space here. So you can decide to leave the space here, or you can put the space here. Whichever way, it's just going to give you that space. So think about it as, joining multiple statements. So now we have printed, so this function is able to print, I am your name. Probably I need something else. I need your age. I am John. You can, put a full stop plus, a full stop, right? Because, and the reason why this is possible is because John, this name is a string. So be very careful. You cannot add a string to an integer. It's not going to work. And it's going to throw an error because unsupported operand type for int and string. That is, int and string cannot be, added together. But what if this two is a string, like I mentioned yesterday, we can have strings of numbers, then this would work. It's going to print 2DEF, okay? So be very careful, even though you want to put a number, make sure that you wrap it, in a string so you can perform the operation. So let's print this. Now okay, now because I didn't include the age yet, okay. So we have the full stop. Okay, I am John. Or okay, we can use a comma instead, since it's the statement continues. Instead, I can say my name is John. Yeah. I am 25 years old. Yeah, it works, right? Now, John, everyone won't be John, and everyone won't be, of course, already this program, this function can, print out someone's name and also the someone's age. But this age, there will be a problem. If I change this John to, let's say, Peter, it's going to say, my name is Peter, I'm 25 years, but Peter might not be 25 years. So just as we have, try to pass in the name of this of someone as an argument, it will make also sense to pass in the age so that we can always, the function can always, work with the age of the different with different persons, not just 25 years. And what we will just do here is instead of just putting 25, we can just, put a plus, put the age, right? And mind you, anytime you're concatenating strings, you just have to use the plus and you have to close the double quotation so that the operation can be possible. Yeah, so now we have Peter. Let's say Peter is 40, right? And what do you think would happen? It's going to print an error. Yes, and this is because for the way I define this print statement, like I said, you cannot add a string, an integer to a string. And what is actually happening here is that age is coming in as a what? As an integer. So age you cannot add string to an integer, right? So what we might want to do is maybe we can just wrap the 40, we can put a space here so that, there will be space between the and the 40. And we can also put a space here. So there will be a space between the age and the years. So, I'm 40 years old. You can wrap the age you know, in string, in a single or double quotation, or I can just leave the age as an integer. But here, remember we talked about casting yesterday, where we can, you know, convert, you know, we can change the data type of, you know, of any item. In this case now, the 40 now is an integer from where we passed in the argument, but right at the point where it's going to print, it's just converted to a string. So it makes this operation possible, and it's just going to work. Yeah, so that's just it. I mean, in brief, I've talked about functions, parameters, and arguments. So what you see here is, just like we have done, this function greets the person passed in as a parameter. Exactly. So what you have here is this function greet as parameter, you know, name, age, you know, these are just, you know, they are arguments, you know, they are arguments. And, you know, you have to feed in that argument. You have to feed the function the argument, otherwise it's going to throw an error. What if we decide to just, you know, remove the age and run this program? So it's still going to complain. It's still going to say greet is missing one required position, and it specifically states that it is age. You are missing the age, because when you are defining the function, you are saying feed me with two, you know, two parameters. And while we were calling the function here, we are just feeding the function with just one, right? And so it's going to throw an error. So we have to ensure that it is two. And if by any chance you define a function with two arguments and you are passing three, let's say somehow it is asked, maybe you don't know, and you just include the city, let's say Lagos, but it's still going to throw an error because you have created a function with two arguments, but you are passing three. And it's going to say, no, the function greet takes two positional arguments, but three were given. So it's a garbage in, garbage out thing. What you define is what you, you know, you feed the function with. You can continue feeding the function with multiple, like any numbers of arguments, and you know, it's fine. Now let's talk about return values. All along, we have just been printing. And sometimes it's always the case that, you know, we want something in return, right? It's just like you, you know, you want to, how can I say? Okay, you go to, yeah, you take your car to the workshop, right? And think about the car as, you know, as the parameter here, right? And the workshop, of course, the workshop expects a car. Then you take the car to the workshop, and of course, you want to come back for your car. So you want the workshop to return your car back, you know, repaired, right? And all along, what we have been doing here is just, we have not been returning anything. So we are just calling the function and everything just goes blank. So the print statement doesn't hold any information. It just displays the result on the screen. But the function, the return would ensure that something is returned. Now, this is a simple function. Already we know what an argument is. It takes in two arguments, x and y. This is a simple function that sums two numbers, right? And we want to return the sum. Now, when you call this already, the name of the function is add numbers. We have talked about that, the name. Then it takes in two arguments, x, y. Here we are passing the first number to be 2. We are passing the second number to be 3. So what it's going to return would be 2 plus 3, that's 5. Now, when you use the return, you need the information, right? You want to store the information somewhere, right? It's just like you tell someone, okay, do something for me, please return this thing. You don't just want the information to, you know, to disappear. And, you know, that is what happens here. So this result, when you assign it to this function, automatically, when it returns 2 plus 3, that is 5, the 5 just, you know, the result variable that we define here just hold the return value. In this place, regardless of whatever input you are putting, if you say return, how are you? That is what it's going to return, right? It doesn't care. I mean, the return statement is just a dummy thing, and it returns anything you ask it to read. Even though we are creating a function to add two numbers, we are just saying, okay, return, how are you? That is, it has just ignored the 2 and the 3. And yeah, so you have to be careful when you're using return. You have to ensure that, okay, it's returning what you expect. In this case, it's not returning what I expect, because I expect it to add the two numbers, X and Y. I mean, just for explanation, but we want it to return the sum. Now, what if we want to return the product, like X times Y? It's going to return a 6. What if we want to return 2 times, let's just say we just want to return, okay, 2 times X plus Y. In this case, it's going to say 2 times X plus Y. So what it means is it's going to say 2 times 2, 4, and 4 plus 3, 7. So this would return 7. So we can change the numbers. We can use 8, performs the operation. We can use 50, performs the operation. And we can even go ahead, we can even, we can write another function. Let's go back to how we define, using the if-else statement. So you want to know, number less, like probably you want to check if a number is less than a number, So we want to check if a number is less than 10. So you feed in the number already. It can be anything. You can say X, you can say Y, we can use Z. And you want to check, if this number is less than 10, then return Z. I mean, otherwise, don't just do anything. So this is not new already. I expect us to already understand what the if statement is doing. So we are checking if the number we are passing in is less than 10. So let me explain. We want to create a function. We want to check if the number is less than 10. The function takes in one argument, which is the number we want to check. It moves to this line. It would ask, is this number less than 10? If this statement is true, the function is going to output Z. Otherwise, it's not going to return anything. So let's start with 5. So let's hold the result and let's print result. So now we want to check if 5 is less than 10. Yes, it's going to return Z because this condition is satisfied. Now let's check 15. 15 is not less than 10. So what do you think would happen? None. It's not going to return anything. So it's saying none. So nothing happens. So what it means is that this statement is false, and it cannot assign a valid, data to this res variable. But what if I want probably something else, a statement that, I want to be more, yeah, I can just say return else. Probably we can just impose another condition that, okay, if this number is not less than 10, then we can return, let's say, that number divided by 10. So at least if the number is not less than 10, let's see if this condition will work. Already we know 15 is not less than 10. So it will just jump to this next statement, and it's going to divide 15 by 10, and it's going to print out 1.5. I mean, this is because in your function, you can write, function doesn't necessarily mean just do something. Your function can also, include some, conditional statements. You want to check things, you want to verify if what you're doing is true. Probably you are working with data, you are working with a data, you're working with a data set, and, you have, a particular column that that's of data type, that's of that's of that is string or something, but you want to perform an arithmetic operation, you cannot perform an arithmetic operation on string. Or let's say it's a mixture of different types of data, let's say integer, string, and whatever, and you try to perform an operation like addition or subtraction, it's going to throw an error. So sometimes you want to check when you are probably iterating through the column, you want to check or you want to modify the column properly. You can iterate through the entries, and you can be checking if this item is a string or an integer. And you can check if they are instance of of a string or integer, then it's going to output your result. So this is the homework, like we did yesterday. So I still have something else. I didn't conclude the today's class. So I have another script. I've shared it in the chat, please. We can also go through that so that we can start with the last part, which is classes. Please, I sent the group. I sent this the link to the Google Sheet, so we can now move to the next part. So please, let's check if you have any question, you can ask. We don't have much time actually, but I will try to finish up. So the next part is classes. It's a lot, but you don't have to worry. After the class, you can check. Okay, you said, does it mean function doesn't display anything without print function? Yes, it doesn't. You can only print out something. I mean, a function would only print out something when you say print. Otherwise, it will just do whatever you ask, whatever you have asked it to do. Then, but it's not going to print. The results can only be displayed when you use print. And print doesn't translate to return. So you have to be careful. Like in this place, if you say print, here, this result, print is not the same as return. Print will only just display. And why do you see this? Now, this 103 you are seeing, let me go back to this 3. Now, this 7 you are seeing is this print statement. Because print statement doesn't translate to return, this statement, print result, is throwing none. Because Python would only put this 7 inside this result variable if you use return. If you use print, print cannot assign result to 7. It is only return. So when you use the word return, the function return, it executes this code and it returns the this operation, and it dumps it in this result variable. And that is why you can always print this 7. So let's continue for today classes. We might not finish, but I will try as much as I can to. For the other part, I can talk about it when we by next week, when we are talking about when we start the class on machine learning. Then we can also introduce some of the things. I mean, you can just learn as we continue during the course of this course. Now, so classes are just, we have talked about functions, right? We have talked about control structures, but what is actually a class? So a class is just like an object constructor. It's a blueprint for creating objects. And think about what we have done when we were talking about data types. When you say type 8, it's it's running. So we expect this to be an integer, right? And this is because it's an inbuilt thing, I mean, that is just it. It's an integer. We don't know how it got there. It's something that is inbuilt. It's just something that is built. Or we say John, it's a string. However, we can start to create our own class. I mean, we can create objects. We can assign whatever object we want. Just like, how you have objects like integers or dictionary or something, we can just create our own object. And when we talk about object, I mean like classes, like, a class is like an object. So when we are talking about object-oriented programs, we talk about, classes, because classes, classes in a way, is particularly used to, to create object-like, things. For example, you want to create an object called student. This student has, it has a name. It has, the student object has, age, for example. It has, let's say, your email, and things like that. So you can assign, different attributes to this object. And how do we create classes? Just remember, when we're creating functions, we use def, right? But in classes, we just use class. It goes with also the class name, and we can just immediately create a class object. Very straightforward. We didn't do anything. We can just create a class, which is your first class object, just like a normal function, just as you would do, right? And, we can come here now and we can print out the object. So now I'm going to explain. So so when we are creating objects, we talk about, attributes. So an object would have an attribute, something like that. Think about, a room, like, a room object. In that room, let's say you have a table, like that's one of the attributes of a room, as I expect. A chair, a bed, if it's a bedroom, yeah, at least as far as I can tell, typical rooms would have a bed, or let's say a wardrobe or something. And, yeah, like someone also said that you can use function for any series of code you want to use many times. Yes. I mean, that is what you use function for, because just as we created that function to add numbers, we can use it multiple times for different numbers. I mean, so yeah, so back to classes. So we talk about objects, we talk about attributes. So now when we created this class object, my first class, we created this attribute, X. And, how do we access this attribute X? So in this case, think about X as the attribute of the class. It's just one of the attributes. I'm still going to create something that makes sense in the next line, but just think about, okay, X is an attribute. It's just an arbitrary class. It doesn't represent anything. So how do we access this attribute? Just like function, as we did, you define a variable, you define the function name, and it can take argument or not. It's just the same way we do in classes. In this particular class, there is no argument. And that is why you see that there is nothing in the bracket, right? And how do we access this X attribute? You just put a dot X, and it gets the attribute, right? Yeah, indirectly it translates to a kind of return, statement, you understand? Now, let's be more creative, because we just created a class. It doesn't have any meaning. As you can see, we create a class named my first class, and it has a property, an attribute, so to say. And, we can access this attribute by, the name of the class, that is the name of the instance we use to instantiate the class. The variable we use to instantiate the class. And then we can call this instance we can call the attribute on that instance, p1.x. If I say here is f, then I will have to call f.x. Now let's go to, let's define a function in a nicer way. Now, remember the last time I talked about, we can create a function like, student. So in this student, typical student must have a name and a grade, right? We can even continue to add more things, name, grade, department is also something that is very, department. So in classes, unlike functions, this is how you define the argument. So in function, we just remember I can also go to my screen here. Yeah, we can just directly put the bracket, the arguments in this bracket. But in classes, we have to define a constructor. It's a dunder method. So because of this double underscore, so it's a double underscore. They are called dunder methods. They are special methods in classes. We have several of them. I would also mention, I will talk about them briefly. And what this would do is it will just instantiate, it takes in the argument, name, grade, department. And at the time where you call the class student, it automatically is. So what it means is that immediately as we are calling this student, the whole of this thing here is just at once would instantiate. And well, just as we probably I shouldn't just go straight to this, but let me do something up here. Great. Let's say something like this. Let's say department chemistry. And here we want to call the student, right? So we want to call the student 1, the first student, that is our first instance. And you already know, right? And remember, you can call, so in this case, these are some of the attributes, right? These are some of the, just like we have X. So the same way we called f.x, here we can call student 1.name, right? And we can call, I can just print on the second line, student 1.grade and student 1.department. So now, what I've just, so why I have to do this is so that the next line would make sense. So just as we have done before, now I just created a class. Now, it represents something, student. Here, the name of the student is John, the grade this, the department chemistry, and just as we have done, we can, instantiate our class, and we can just call the attributes. Remember, in the first illustration, we use X, right? The X is just, so now the attribute of a typical student is name, because every student must have a name, unique or not, but a student must have a name. And the grade, 4 point, just a student would have a grade or a department. And let's say matric number. Yeah, matric number is also something very important. So let's say matric number, we can always put it in string in case it starts from 0, because Python doesn't accept 0 for a first number unless you put it in string. But let's assume it's not a string, like let's say, okay, 2023 and some numbers, and we can just immediately come here to print the student matric number. So now what you see here is just some student named John with this GP, department, and this matric number, right? So we have created a class object for John, right? For the student 1, rather. Now, what if I go to the second line and I want to create another student 2? So think about it, student 2. Because it's a class object, I can call it multiple times, like function, right? And I want to print out this same thing, right? I want to print out the student 2, but instead of student 1, now it's student 2, right? Student 2. Oh, sorry, student 2. and I run. Wow, something crazy would happen. Now, what I just see is the same John, we find here. It doesn't make sense because even though we have two different instances, student 1, I expect to be different from student 2, we still have, the same result. It doesn't make sense, in real application. We want, things that are different. Student 1 should be different from student 2, even though they have the same name, but they can never have the same matric number, as far as I'm concerned. And you can have someone from the same department, the same name, but I'm very sure their matric number must be different. So there is no way we would have, an exact copy of student 1 and student 2. And in this case, we want to construct our function in a way that it accepts, different entities. You understand? Just like how we did in function. Remember when we were, when we printed, hello Mark. We didn't want Mark always. You understand? We want, this name to be an argument to the function, right? Such that when we impute the name, it prints out, different names, right? It makes sense. But in this case, also more or less the same. We want, different student names, matric number, department, and things like that. And that is where this constructor comes in. And we use the constructor when we want to, define unique instances. And instances are just, like, they are just like children. Exactly. So I just put it like that. Children of, there are things like, we construct the instances based on this object. So this object defines, this instance. For example, I have 5 students. I want to define the 5 students with this, object here, and it makes sense. Now, let me add the department. I'm also going to add the grade also. So we have name, grade, department, and we have matric number. So please, and I'm still going to explain what this self means. So I can just department, equal to department. Then we have self dot matric number equal to matric number. Yes, so now, yes, now, like I said, this is a constructor. Constructor always comes with this dunder method, which is underscore underscore twice init underscore underscore. So it means something like initialize. So it's a constructor. The moment I call this student class, it's going to just immediately initialize. And okay, so now we have our object, we have our class object, right? And let us create our first instance. So what is this self? In Python, Python expects, so the self, just like as I wrote in the code, it represents the instance of the class. So it's something that uniquely defines that instance, right? It's just like when you say myself, I am me, I am not you. I can only be myself. So when you want to refer to yourself, you will say myself, right? So think about this self as something that represents you. It represents the instance of the class. It represents me. I'm the instance. I'm an instance of this student class, right? And we use that self as a pointer. It's a pointer. It points to you. When you say myself, it means you are pointing to yourself. So this is me. Python recognizes that, okay, this is an instance, a unique instance, and everything that happens within that, within that instance points to only that instance. So it's not transferable. You cannot transfer, something within you to someone else. So now we have defined our object. Makes sense, straightforward. So here we have to call the self.name. Now, what this now means is, so because we have defined this self, initially, when we define the first class, you notice how we use this student1.name, student1.grade to access, these attributes. These are the attributes, right? These are the attributes. So think about this self.name as an attribute. So the self always still points to itself. It's just an instance, and I will explain what this means. Yes, so we create our first student class called Alice, which is the name, grade. Let's use something, yeah, let's just say 3.75 or something, out of anything, 4 or 5, doesn't matter. Department, let's say biology. I mean, I'm just assigning something. So already we know what that means from the function, example. It's not difficult. So we just define the name, the first argument, because it's a string. Grade, we can just leave grade as float, doesn't matter. Then now the last one, matric number, let's say this. Now let us print S1. So that's the first student, S1. So when we print S1, now what you see here is just it just print out some kind of object. So you see that it's a student object, right? It's a student object. Sometimes we don't want this, right? We want this doesn't even show us any information. It's just saying, okay, it's a student object at something, just pointing at somewhere. Probably we want to use yeah, we want to use something. Yes, so please, can you hear me?
Yes, I can hear you.
Okay, thank you. Yeah, so we want to, we want the result to, I mean, we don't just want it to print some kind of odd statement here. We want it to make sense, at least such that when we print an instance, we just see that, okay, this represents something, and, yeah. So how can we just ensure that, we print out, we just print maybe some information about that student, right? Let's say we just want to, print the student name, right? So what will happen is, initially we see some kind of odd things, and now we have also used, so there's this Donda method. There is also one called I think it means represent or something. So what it's going to do is, it's going to kind of, when you call the instance, when you try to print the instance, it's going to return whatever thing, information, something like an added information. So when you say, self.name, just, okay, this is Alice, or you can just say return self.name plus object. So, at least you are trying to add more information to, to where, like, to someone that doesn't even know what this is, because if you remove this statement, it doesn't say anything. This cannot even, you don't even know the student. I don't even know if it is Alice or someone. But if you can say, okay, let me use something that can actually give more information, something that is human readable, something like a representation. So that is what it represents here. It's just a representation of the instance, and you can give it anything you want. So Alice object. So that is cool. Now we can now go further. To print the attribute of an object, you use the dot, right? And even before typing anything, you can see already Python just already displays the 4 attributes, at least for now, of this instance. And you can see the instance, the department, the grade, the matric number, the name. So when you print out the, let's start from the name, it prints out Alice, right? We can also continue to, print the grades, right? We can print the department. We can also print the matric number. And, we get everything about Alice. Now, let us create another instance. So when I mention instance, just see, instance is just as an example. I just want to create something, an example of something. So they call it instance. So a student 2, let's say John. Let's say John, let's say this. John is in chemistry department, and let's say the matric number is just, yeah, I just modify. And now let's print S2. Now, what you see, so if you remember, when I added this, this dunder method, it always prints out the name of that instance object that we have created. For Alice, without calling any attribute, it prints Alice object, right? Because this is for Alice, right? Now, when I want to print for this second instance, it's going to say John object. So it's a pointer. So it's something that it makes it readable to someone who doesn't even know what the instance of that object is. So now I don't have much information about John, but I know that this is John object. I know that this person here is John, right? It might always be the case where, well, I don't need the person's name because, yeah, I think name makes sense, or maybe matric number, because matric is unique. I think it makes sense to use a matric number. Okay, yeah. It cannot add a matric number to an object. So what we can do is we can just put a string, because already the matric, and we did not impose any condition on what our grade should, our matric number should. So I used a string, just an integer. Usually you might want to use string or something, but remember, you can just cast it as a string, and you see that it gives us the matric number object. So it makes sense. Let's use the matric number since it's unique. Here now for John, so it's now going to show us. So we don't know any student by name. We assume students are uniquely defined by their matric number. So we can just define, we can represent the student with the matric number. So let's print out some of the attributes of our second instance. This is John. We also have grade. We also have the department. Then the last one, we have the matric number, whatever. Yeah. So now what we see is just, yeah, this is John. So we have John, we have his matric number, grade, we have the department, we have the matric number. And now you see that it's different from Alice. Now we have John. Unlike when we started, even though I created two instances, I was getting the same result. This is because our class didn't take any argument, just like how we have in we illustrated using function. So when you want to define unique objects, we use the init, the dunder method init that takes in that argument, and we have to use that self, right? I think the self is just it's a Python. It's custom. I don't think it's a do or die affair. We have to use self. I think if you use something not even self, I think it's still going to work. Yeah, so it's going to work. But because Python just assumes, from a more realistic view, the self would better represent something that represents an object. So, but if you want to use something else, you would have to be consistent. You can say, you can use me. Yeah, you can use me. You can use whatever you want to use. But I think it makes sense to just stick with self. To stick with self. Yeah. Yeah. So I think that's just it for classes. There are other nice things in classes like inheritance. We won't talk about that, but you can also read about it. If you look at the the links I sent in the first slide, we can always, we can always, go through these links and, and yeah, we can always read about it. So the Donda method I've talked about, the Donda method, I didn't say all, at least we talked about the init, we talked about the represent. We also have the get item. This get item is also used when we want to get you define an object of list and you want to extract these items. Then you can index them. You can index. You can index with this Donda. You can read about them. You can also call. You can also call. You can use the call method in a function such that you can more or less like calling a function on an instance. So it works like a normal function, right? Just like when you define a function and it takes in some argument. When you use the call something, then it works like that also. Probably we could try this. What does it mean? We can just try the call. Let's say takes in some self, takes in some maybe you want something that returns that returns I mean, for any instance that you call, you want to return hello or something. Yeah, I don't know. Yeah, just return hello or something. Or let's say, yeah, let's try. And yeah, we want to pass in an argument or something. No, not, let's say x something, then x times x. Yeah. Yeah, then because now we have our instance x1, I think we can just call this thing on. Yeah, so basically that is what call will do. So you see now what we have done here. So when I created this call method, so it comes like, it's a Donda method, but it takes in an argument x. This is irrespective of, it doesn't have, it might be linked or not even linked to this attribute. Something, maybe you just want to do something that you can always call on any instance, and you just want to create some kind of, side method that will just output the square of a number. And even on my first instance, I can just immediately do that, right? So it's going to output 81. I can also do that on S2. So it's still going to, to show me the same result. Let's say I use 10, it's going to print out 100. Oh, sorry. Okay, I didn't instantiate because the last time I didn't include it. So now it's going to print out 100. So that's what call we do. I can't do all, but if you check the Python documentation, you will see lots of methods. You also have forward. You would also be using the forward. There's also a forward Donda method, which we would be using also when we are doing deep learning. Yeah, I think if you look through the script, I don't have much time. Yeah, but I will try as much as possible. When I'm introducing PyTorch in the third week, I would talk about NumPy. And in the next class, which is Introduction to Machine Learning, where we would also be working, no, sorry, not Introduction to Machine Learning, I'm talking about exploratory data analysis. We would also be working with pandas. Yeah, my colleague and I would also, talk about this. So don't worry. The NumPy also is something we would also talk about in the third week in Introduction to PyTorch, because they also work also in a similar fashion. So NumPy, PyTorch, they are just Python libraries we can use to, for tensors, we can use them to define, we can use these libraries to, to define arrays, to do operation, to carry out several operations in arrays. Also in Matplotlib, you see these things also by next week in the in the exploratory data analysis section. So you can take your time to look at this. You can play around with it. I also talked about data storage. We have the int 16. So I also explained it quite well. You can also read about it. These are how, this data we have been defining, we have been defining data 2, 3, 4, how are they stored, in the memory? They're stored as bytes, right? And, we want to know, in how many of these bytes, does the computer, store this value? So when you define an integer, how do you want to define this storage, the memory in usage? So you can have it in 16-bit or 32 or 64, same as float. That is, we want, please just go through this note as I explained here. Also, when we start to work with machine deep learning model, when we start working with neural networks, we're also going to find these things. So yeah, these are just the NumPy, nothing much. The pandas we will do next week. Yes, but I would really encourage us to go through the script so that by next week, it's easier to just proceed. But nonetheless, we would also cover some of the basic things you would need to get started, Yes, I think I would stop for now because it's already 2 hours and I think it should be enough for today. So I would leave the floor to, are there any questions? Okay. Yeah, I don't think that.
I was answering most of the question as you were talking.
Yes.
Some of the questions were on classes, but I guess it's maybe too close. There's no time to really dive into it. But if there's any particular question, please feel free to ask on the chat now.
Did you already add the Slack? Did you send the link for the Slack so that we can also share information there?
Yes, that's true. We can also have a forum for people to ask questions and for discussion on Slack, which I posted. I can post it again.
Okay.
A minute. Okay, I can add it to the post again. Okay.
Okay, someone was asking, there are also, this app can run on your PC. Yeah, so many questions. Please, if you have questions, you can join the Slack channel. Please, you can, did you already send the Slack channel?
Yeah, I posted the link for them to join.
You can also send your questions through WhatsApp. We are on WhatsApp.
Oh, yeah, you can use WhatsApp also.
We can use WhatsApp, we can use Slack. WhatsApp. I will try my best to, to answer. If you have questions on classes, functions, or some of the assignment, the homework, just for practice, please, you can download also this slide, this script so that you can, I give some simple assignment.
Please, can you download both of the 2 notebook and put it on WhatsApp? Because look at people are using an Anaconda, so they can just.
Okay. I would even just put the link to the script.
Okay, yeah, you can put the link also. Yeah.
Yeah, so we can also discuss further. So because we have limited time here, and I won't be able to answer all questions. But if there are questions, I can try Slack.
Oh, someone said WhatsApp group is locked. No, it's open. You can. Let me post the link again.
Yeah, thank you. Yeah, thank you. And yeah, it was a lot of things to learn, but I think I've presented you with some of the things you might need to hold on to as you continue to learn and yeah, read documentations, practice, and yeah, just play around with it. You can do some testing and yeah, things like that. Thanks a lot for your time. Tayo, are we done for today?
Yeah, I think we're done for today. Everyone, please, I'm posting the chats, the WhatsApp link.
Someone said only admins can comment on the WhatsApp group. Please, can we remove?
No, you can. That is true. Only admin can comment. Okay, we will change that everyone can comment. So we're going to change it right away after now.
Okay, thanks. Yeah, thank you all.
How is attendance taking this class? Okay, yeah. So the attendance is taking. So because we are using Zoom, Zoom has a record of when you join the meeting and when you leave. So we have the time. If you leave, if you come in, we have the time already recorded. When you leave, we have the time. So we can always know if you were present or not. So there's no need for you to write names or anything. It's fine.
All right. If there are questions, you can just ask.
Someone asks, what's the difference between Anaconda and the one you are using on Colab?
Okay. So yeah, I didn't talk about it. So Anaconda itself is so we are using the Python programming language, but Anaconda is just, you can see Anaconda as a wrapper. It's a wrapper that has the the Python. That has all of the Python frameworks that you would need. Okay, and we have the Python compiler. We have also nice interactive sections to write your code, like Jupyter, Spider, Jupyter Lab. In as much as for time's sake, I didn't run this thing locally, just to save time of installation problems. However, if there are questions, I can. If you're having Anaconda is not different from what I'm using. It's just like Anaconda is just this is Google Colab. It's also an interface where I can write my Python script. In Anaconda, you would usually find IDEs like integrated development environments like Jupyter. Jupyter is just like this also. And you can also write your codes in Jupyter, but it runs on your local machine, right? Because it's your laptop. But this is hosted on Google. It's a cloud-based IDE where we can write codes. So Anaconda is a wrapper. It has the Python compiler, and it has very nice IDEs where we can write code that's user-friendly. Okay. And so, but at the background, when you use this, IDEs like Jupyter Note, what it does is, it goes to the back end. The compiler does this thing and throws it out to you in a friendly way, that you don't have to write codes in terminals or something if you're not really used to this terminal writing codes on the terminal. So they are the same. It's just it's a wrapper. It has everything you need. You don't have to start downloading them one by one like Python. Software. You download the Python compiler. You download the Jupyter Note. You download like any environment you want to. But Anaconda has all of this. So Anaconda just does what you want to do in Python with a nice layout already set. You have everything you need. Yeah, this one is also, I can run my Python script. So, but it's not Anaconda, it's a Google Colab. So it's the same. The same in the sense that it achieves what we want to do, which is Python programming, nothing more. No, you don't have to download Jupyter before using Anaconda. Like I said, all of this, if you download your Anaconda, you can open the the Anaconda when you open your Anaconda, you would see all of this all of these things. So yeah. So yeah, I think that's just it. Yeah, please, once you have downloaded your Anaconda, you can try to search for your Anaconda Navigator. So I can type it on the Anaconda Navigator. Anaconda Navigator. So you can see, you would see some of these, you see the packages that comes with your Anaconda, right? And the Jupyter is there. The Jupyter notebook is there. You just have to, if it's not installed, if it's not active, but I think usually Jupyter comes by default. I think other ones you can manually, you can just click. I don't know if I can, this is what you, I'm coming. These are just for technical things. I think we are literally done, but if you, yes, if you're with me, I've downloaded, already have Anaconda on my laptop. Whether you're using Linux or Windows or Mac, you can open your Anaconda Navigator as I've typed. And mine is trying to open now so that I can show you what the Anaconda Navigator looks like if you are very interested in running this thing locally. So, yes, so if you are with me, this is how the Anaconda Navigator looks like. I don't know if it's too tiny. I don't know if I can zoom this guy. No, you cannot zoom. Tayo, can you guys hear me?
Yes.
Okay, yes. So please, I think if you want to remain, it's just for technical things. So this is your Anaconda Navigator. Like I said, Anaconda is a wrapper. It's a very nice wrapper. You see, this is Jupyter Lab. It's just like the Google Colab we have worked with. If you launch it now, it opens. You can run your Python script. This is the Jupyter Note, also like Google Colab. This is the console. If you like to write codes on console, which is nice also, you can try. This is Spider. Spider is also another IDE Python code. We also have the VS Code, which is the Virtual Studio. You have these app tools. You don't need all of these. Yeah, you have quite some things. And I think with time, I would also explain why we have to create environments. If you're working with local machine, if you're working on your local machine, but since we're working with Anaconda, we won't be doing all of this, but I would send nice documentation on how to probably get started on your local machine. Yeah, I think this is all I can say.
Okay, so the WhatsApp group is open now. You can make a comment. So there's no problem. So you can ask your question there. It will be open for the period of this training, but after the training, we will close it back. The reason why we closed it was because we didn't want people to post anything that does not relate to this platform. You know, people like to advertise. Please, it shouldn't be used for any advertisement. If not, if I see any advertisement, I'm going to remove it immediately. So your question is only for you to ask your questions, please, just for questions or anything related to this training. After the training, we will close it back so that anyone won't be able to make comments. And if you have a question, you want to talk in person, I think you can uncomment yourself now.
Okay, yeah, I think it would be nice. If you have questions,
you can unmute yourself if you want to talk directly.
I can stop the recording now, right?